So first of all, I would like to thank you very much for inviting me to give a talk on this topic. As you said, I'm a professor at the University of Bordeaux, and I had a department working on cancer biology and also angiogenesis. So first, because I'm in Bordeaux, so the first introduction I will show you where I am, and in fact, I think British people know this place pretty well because they have been there for 300 years. So, so it's, and of course, it's a famous wine region. As you can see here, you have the Chateau Cheval Blanc, which is one of the very famous French wines. But this region and Bordeaux is not only famous for wines, but there's also some good research going on in several areas, of biomedicine, in the neuroscience, in cardiovascular biology, and also in cancer. And in this context, I'm heading this lab, this department on angiogenesis and the tumor microenvironment at the university since several years, which is affiliated to the National Institute of Health in France. So what I will talk about is first about truth in the biomedical science. That means first the definition, what we understand of truth, then the issues of truth and its criticism of it, because philosophers have in fact criticized a lot this notion, then the strategy and the methods to uncover truth in the biomedical sciences, causal theories, because they are extremely closely linked to truth and the notion of truth, then the notion of solidified truth. And then, so I will conclude with some of the case studies, interesting case studies with Semmelweis, which is a very interesting case studies for the notion of truth and how you investigate science and do that. So there is a really great example. And then the COVID and cancer. So the notion of truth, when you look in the Webster, in the Merriam-Webster, there's a lot of definitions of truth that you can see. There, for instance, the body of real things, events and facts, the state of being, the cases, transcendental, fundamental and spiritual reality, and so forth and so forth. But what we understand more or less about truth is a property, or maybe as a statement of being in accord with the fact or reality. And of course, you have what we call the more or less the factual truth, and you have also what people call the moral truth in terms of ethics. But we are mainly interested here in the factual truth. So there are a number of issues in truth. There's truth versus certainty. So what is the difference? Can we have, in fact, in truth and in the investigation of the world and of science and of biomedicine, can we have also certainty? Is truth only provisional thing? Because in physics, and a lot of physicists in the physical science, they speak more or less often about provisional truth because there's all the time a revision of truth. But is there also what we call more solidified truth? Then there's another aspect, which is the fluctuation of truth during the discovery path. Because when you discover things, your hypothesis may change. They may significantly change and be altered on what you find, and will give you new orientations where you go. It's like to turn right or left when you walk on the street. And there's also another aspect, is the language. In the biomedical science, when you look on the language that is used in biomedical science, it's often a language that labels things and that put things and objects in relation. So there's now also more formalized effort in the biomedical science, for instance, to do more artificial intelligence deep learning and things like this in the science. So this will, of course, all these efforts that's stemming from the formal science will significantly impact in the future the biomedicine. And there's also the biases. You have a number of biases, and the verificationist principle, when applied alone, is a very big bias. And we will talk about the verificationist principle a little bit later on. And there's the notion of scientific relativism and the problem of truth. So there's, of course, the relativist is, there are in fact a number of forms or types of relativism. There's the strong relativism, there's the smooth relativism, there's more or less, there's the cultural relativism, there's an epistemic relativism, and so forth. And this poses, of course, a problem of the notion of truth in respect to science, and especially in respect to biomedicine and bioscience. And truth and causality is closely linked, because the causality is the means, in fact, to find truth when it's enshrined in facts. So there's been a criticism of the notion of truth, I mean, in philosophy by a number of philosophers, and I cite only here a few. Friedrich Nietzsche, for instance, for him the truth was a kind of error without which a certain species of life could not live. So he was a little bit influenced by biology, in this respect by Haeckel, I believe, and it was just a kind of toolbox for him for life and for the species to survive in an environment. Then there are also other people, more or less stemming from philosophy and physics, Paul Feyerabend and Kuhn, Thomas Kuhn, where, for instance, Paul Feyerabend, where he wrote a well-known book against the method, but this was mainly a criticism against the philosophical tendency and proclivity to establish philosophical truth as a formal thing. That for him, in fact, science has to do just this job and go wherever it goes. Of course, his famous aphorism, anything goes, was a little bit too extreme. So there was a risk to relativism also for him. Then Kuhn, Thomas Kuhn, with the scientific revolutions, of course, it's not, I mean, it's a criticism of this kind of truth that starts during a period in time, for instance, in the 12th century, 15th, 16th century, and it's not like a gradual increase of truth and knowledge. In fact, how it sees this on, it's a kind of waveform and wave behavior. So it's a little bit close to relativism in that respect. And there's also Foucault, Lyotard, and the postmodern philosophers that were more or less influenced by Nietzsche to some extent. And in fact, for them also truth has no real meaning, and it has been essentially replaced by power. So now the strategies to uncover truth in biomedicine, you have two ways to do that. You can do it with hypothesis-driven approach or data-driven approach. So you start from a hypothesis, you formulate that, and then you do the experiments and go down and test it. And there's been in Nature in 2010, two point and a counterpoint. The first was by Bob Weinberg, who's a famous cancer scientist, famous cancer researcher, and who for him, hypothesis first, we test the hypothesis, we explore, then from this hypothesis, we do experiments and test them, and we advance like this. And the counterpoint was proposed by Todd Golub. It's the same here. I mean, both people are at Harvard, and he said, no way. Now the technology has become so great that we just can approach it to obtain data, and from the data we will scan the data, and then we will establish hypotheses from the data afterwards. So this can be done in two ways. As I said, the first is the data-driven, so an experimental method that provides data, for instance, DNA sequencing, RNA sequencing, imaging data. These data are then scanned for regularities and patterns. Then hypotheses are elaborated based on this data, and afterwards they are tested. And the other thing is the hypothesis-driven approach, where the hypothesis formulated experiments are designed to test the hypothesis and to accept or reject it and to formulate a new hypothesis. And in fact, one can formulate the question, can we ever escape from some sort of hypothesis? And the answer is clearly no. Even if you look on the data-driven approach, there is some hypothesis there and always there, because often the data-driven approach, you will compare two settings. For instance, you will have, let's say, a group of people where you do, for instance, genetic sequencing and analysis that has a specific feature, and another group. You will compare both. So at the beginning, you already start to some extent with an hypothesis. So to my belief, its hypotheses are not escapable. Now, what are the methods in the biomedical science to obtain truth? Of course, you have causal inference, that is the basic method. You have the Bayesian statistics, you have the Aerostatistical approach, the inference of the best explanation, and the nomological network of cumulative evidence. Now, the causal inference, this has been proposed by John Stuart Mill, and he said, if at one time an event takes place and another time it does not take place, and all conditions are in common except one, which exists only in the first event, the condition which is different between these two events is the cause or an indispensable part of the cause of the observed phenomenon. So this is the method that is often applied in a lot of settings in biology, but it needs to be reinforced by additional conditions and criteria. The two conditions that are compared have to be homogeneous. The agents or the potential causal mechanism of the induced response must be present only in one of the situations, absent in the other. And other factors that may interfere must not be present at the time of the experience. So this is often, for instance, what is used in fact, on a daily basis when you do an experiment in the lab. For instance, you have one condition, then you have the other condition. You treat condition A with an agent, a pharmacological agent, or you knock out, for instance, a gene in one cell type, and then you look what happens in these cell types, and you compare to the normal state in a situation where you did not do it. Okay. And then, of course, you can do rescue experiments and all this. So there is, you can make a causal connection between the molecular alterations and the phenotypic alteration using this approach. Now, the Bayesian approach is now, it has come into fashion since several years in biomedicine. In biology, I mean, it's a more or less a statistical approach, and is used often in genomic for the analysis of genomic data. So this is a statistical approach that assigns a probability to an event in relation to another condition. So the probability of an event associated with the condition X is the result of the probability of X multiplied by the probability that the event associated with it occurs, divided by the probability that the event occurs on its own. So this is the standard probabilistic equation that you see here, where you have the probability of A associated to B is exactly what the sentence is stated here. So people who people who can read this equation understand this pretty well. So this is the second method, pretty much in use for genomic data and large genomic data. Now there's the Aerostatistical approach and method, which evaluates with which a hypothesis will pass a test. So the chances of the null hypothesis is if it is successful passing the test. So if the probability of the null hypothesis is high, then the observation is not due to the causal link that is considered. Now you can have in this respect two types of errors, what we call type 1 error and type 2 error. In the type 1 error, when you reject the null hypothesis, you can accept a potential false alternative hypothesis. And then you have the type 2 error. When you accept the null hypothesis, then you might reject the potential valid hypothesis. So this is an approach that is pretty much also in use. So another approach is the inference to the best explanation, which is really an interest in biology and medicine. And this approach may fill the gap between inductive inference, which is exclusively based on causal links, and the mechanistic explanations. So there is, what is important here is the mechanistics and also the concept of structure, of topology, and so forth, and feedback. So now another method that is the nomological network of cumulative evidence. So this stems, in fact, from psychology and also evolutionary psychology, but it has been used, in fact, in the life science since a long time. For instance, Charles Darwin did it. Charles Darwin used a nomological network of cumulative evidence to formulate his theory of evolution. So you need, for instance, you have one phenomenon you want to explain, and then you line up a lot of evidence that in fact independent and which points to the same explanation. So you can have a lot here. For instance, you have up to 8 evidences that are here, and you can so you can apply it in a lot of settings. I mean, it's like when you, for instance, want to put someone on trial, someone in court. You know, you need not only one evidence, but you need more to have him guilty at the end. And you will see afterwards. So I will show you an example of this afterwards, specific and concrete example. Now, causal theories. Causality, there's the metaphysical aspect of causality and a methodological aspect of causality. And the second is interesting to us. Of course, the causality has been proposed by a number of people from the ancients, from Aristotle. Is really the old doctrine of the 4 causes: the material, the formal, the efficient, and the final. But this is not very useful to us. But then there's of course the John Stuart Mill, the causal inference that I already showed you. And there are 2 new ones, the Judah Pearl one with the causal networks, and the James Woodward, which is the interventionist theory of causality. So, and I will just highlight this James Woodward theory. So it's pretty interesting. So you can read this in 2 papers. So James Woodward is a philosopher who is who comes from physics originally. He's still alive, born in 1941. He is teaching in the US, and 2 books. One is one book, Making Things Happen, the theory of causality, and there's also an article that is more or less related to biology, which is very well written, very understandable, that you can read. So for James Woodward, the causality is, in fact, if you consider the following characterization of what it is for X to cause Y, where the cause here means something like X is causally relevant to Y at the type level. M, the X causes Y, and if only there's background circumstances B, such that if some single intervention that changes the value of X and not the other variable were to occur in B, then Y or the probability distribution of Y would change. So this is this interventionist thing that in his idea, only intervention can really, let's say, solidify a causal relationship. And there are also additional properties to consider. So there's causal stability. So the relation X and Y holds when you change the background information, and when you change it in a number of times, then your causal relationship may be more stable. Of course, when you change the background information and the causal relation is not more there, then of course it's very sensitive. And then the causal relationship will only apply to a specific setting. The other thing also to discuss, there are the notion of counterfactuals. So what's happened if this relationship is not, if X, for instance, is not occurring, so what's happened to Y? There's another aspect, is the causal pluralism. So it's a parity. Can be for one phenomenon independent layers of causality that in fact are not talking to each other, but are independently valid. And this is of course different when you have only a single explanation, a monistic explanation. And another point is causal specificity. So one cause and one effect. And finally, downwards causation. So you may have an external framework that may impact on a lower level. And I will show you an example of this afterwards, because you may have a physical explanation of a biological phenomenon with purely physics, for instance, stiffness of a tissue. But then you have all the biochemical and the molecular things, and the biochemical and the molecular, they are sitting on another level than the physical property. And this there may be also downward causation in this respect. So, solidified truth. So is there anything what can be named solidified truth? The problem is that, of course, a lot of people, they will deny it. They will say, of course, there's only provisional truth. You test the hypothesis, it will be valid for some time, and then it will be rejected, and then will be a new one, and so forth, and so on. And this is, let's say, in part truth, but when you look on the history of medicine and of biology, and then the picture and the idea changes a little bit. So of course you have this stability fluctuations and so forth, but what I call solidified truth is maybe this, what you see here on this slide. For instance, the cell theory. Cell theory, life, the organisms are built by cells, and I don't the probably is very unlikely that you will find an organism that is not built by cells. There's also the germ theory, that you have microorganisms and viruses. Very unlikely that you have something else, that this germ theory is wrong. The blood circulatory system, William Harvey. Very unlikely that in a vertebrate organism you will have another system than a blood circulatory system. Then some intracellular things like oxygen, the respiration, and energetics, cell energetics. This is also seems to me pretty solid. Then the DNA as a substance of substance of heredity, and then the mRNA, for instance, the unstable intermediate for protein synthesis. And the mRNA now, of course, is very important now, as you know, because of the vaccine, the mRNA vaccines that came out. So I believe that this is a few examples of what I would call solidified truth. Now, for instance, the circulatory system is here. So I've done a lot of work on this topic, and I wrote out also 2 books about it. So you had when you look in the pre-Harveyan phase, you had the Galen theory of circulation. So blood was in fact formed in the liver, went then to the heart, went from the right heart to the left heart, and then was put in the periphery. And there were no such things as circulation. Of course, there were some also oxygenated blood that came from the lungs, but it was just a tube connected to the lung that in fact injected what people at that time called a pneuma. But of course, this was until Harvey, 1616, the dogma. And the right system is what Harvey found. You have a blood circulatory system that is that is clear, and this will be maintained in all vertebrate organisms. And of course, you had afterwards the refinement of this theory by the capillaries that have been discovered, and then also the cells that are belonging to the vessel wall. Because at one time, people thought there were no cells present in these capillaries. So this is just what I call the refinement of the Harveyan theory. And to me, this is a great example of what I call a solidified truth. Now, case studies. Semmelweis and the puerperal fever, COVID-19 pandemic, and cancer. Semmelweis and puerperal fever. So Ignaz Filippo Semmelweis was a Hungarian, was born in Buda. He studied law first at the University of Vienna, but then he moved afterwards away from law to study medicine, and then he continued his work. He studies medicine. He graduated with a thesis written in Latin, entirely in Latin. So I have looked it up. It's pretty impressive. But then he went to surgery and to obstetrics. And of course, his anni mirabilis was the discovery of the causes of the puerperal fever or childbed fever. Of course, his life was very difficult to some extent because he was outcasted by the establishment. He had a lot of problems, and he published his work, his etiology, which is a very big book, very late, 15 years later after his discovery. And then he published his often a brief, which are, in fact, you will see pretty strong letters to a number of physicians, obstetricians, where he accused them that they do not apply his method. You will see that later. So now, what was his initial observation? This is really very interesting. So there in Vienna, in the general hospital, there were in the maternity, there were two divisions. There were division 1 and division 2. And what you see here, I mean, this is from his original work. And what you see on the right is the plot. You see in the first clinic, the death rate of the women, of the children, was pretty high. Whereas in the second clinic, it was not so. So the thing he thought, what is in fact the reason for that? And then, of course, as you know, puerperal fever, childbed fever is occurring in pregnant women. When they deliver the baby, when they come to the obstetrician and so forth. And it's at that moment that they had in Vienna and in all Europe, everywhere, a really strong occurrence of childbed fever. So it was believed at that time childbed fever was a fatality or a cosmic radiation or atmospheric causes or epidemic unknown factors or woman psychology. Because women, when they are together in a division in the maternity, they may have some psychological disturbances that may jump from one woman to the other and so forth. So this was a theory, and Semmelweis was heavily attacked by criticizing it. But Semmelweis conducted a rigorous study based on systematic testing of every possible hypothesis. And he, in the letter, in the offene Brief to Speth and Scanzoni, he said clearly that in fact I wrote in my Schrift, in my etiology, I explained the causes of the childbed fever and with absolute certainty, mathematical certainty, that there's no atmospheric influences, but there's only the causes are due to the people who taking care of the woman. That means the physicians and the nurses, and this is the real cause of it. So what he did, in fact, is this. He discovered, and he postulated at a time where there were no germ theory, Louis Pasteur came later, that in fact, he observed different mortality rates in two different closely located maternity divisions. And what he saw also from the historical record when dissections were not performed, because at that time, physicians were doing dissections. For instance, the women or the people were dying in the division. They were put in pathology. They were carried to pathology, and the physicians themselves did the dissections. And that's, he said, this was a strange occurrence. Then the death rate was lower in AD 22 when no anatomical dissections were performed. Then there were also time-dependent fluctuations on the activity of the staff where they were doing pathological dissections. There were periods where they had no pathological dissections. Of course, the mortality rate was low. Then the rates have been observed were higher in some foreigners who performed a higher amount of dissections. Then the he excluded also external psychological factors. One external psychological factor was that, in fact, in the divisions, there were always a priest with a bell, ringing a bell, who was walking the floor, and he was ringing the bell each time when someone died. And the idea was that, in fact, it was psychology, and that the women were psychologically primed to have a strong reaction to the bell ringing, and therefore to develop childbed fever, which was not, in fact, the case. And he excluded that because he said simply to the priest not to ring the bell, and the situation was the same. Then Gassengeburten. So this was the birth outside of the hospital on the streets. And they had a low mortality, in fact. So the mortality was clearly linked to the divisions and the maternity. And Kolcheka was a friend and also another physician working with Semmelweis. And he did dissections, but he cut his finger. And he developed the same symptoms as childbed fever. That means phlebitis, peritonitis, pleuritis, pericarditis, meningitis, and so forth. And then what he did is what he said, washing hands with the Chlorkalklösung. Okay, so that means that with his hand washing, he could really demonstrate that it was triggered by the hands of the physician or the nurses who were working in the first division. And then, of course, there was a revision of the theory, because initially he thought it was due to the dissections, but it was also due to other things, because one woman had a cervix cancer, and they were examining the cervix cancer, and of course the cervix cancer was already infected, and they transferred this infection when they were examining the other women in consequence. And the same was true with an infected knee. There was someone with an infected knee, and the person who examined them had also transported the streptococcus, well, in fact, on the hand, and transferred this to the women. And then, of course, he did animal experiments to prove really what's going on. So this is the result of the chlorine wash. You see it in 47 and 48, strong reduction of the childbed fever. Okay, very strong reduction. So it's clear this is an absolute, this is the formal proof that, in fact, there's an agent transmitted, what he called a already septic agent, and sepsis was not yet known at that time. Semmelweis' case was also discussed in the philosophy of natural science by Karl Hempel. So Karl Hempel was a very important philosopher. He died in 1997. And in his book, Philosophy of Natural Science, he discussed, in fact, the work of Semmelweis, an example of Semmelweis, as a simple illustration of some important aspects of scientific inquiry. And of course, so I already explained to you, I will not read what Hempel wrote here. In fact, so he, as I already said, made really a systematic inquiry of hypothesis testing. So what did he do, and what Hempel, when you read the Hempel book, you will see this. He eliminated a number of hypotheses by observation, simple observation. For instance, the diet problem, the crowding, because they were crowding, the idea of cosmic radiation, the atmospheric causes, all this was eliminated by simple observation. But he has also interventionist approach, so this style of Woodward would say, which was the priest ringing bell, the bell, which he eliminated, or the position, for instance, of the pregnant women, because one theory was that in fact, when pregnant women are on the back, they will develop childbed fever, but when they are on the side, they will not. So, in fact, he tested he had the hypothesis and the test implication of the hypothesis, and therefore he could reject a number of things with this. So if H is true, then so is Y, but I is not true, so H is not true. Of course, you can, to some extent, in the scientific theory, you can have also what we call auxiliary hypothesis that will reframe a little bit the hypothesis and try to rescue the hypothesis. But in general, this is one way to proceed. But on the contrary, you have the fallacy of affirming the consequent. So you may have a hypothesis and you may have the test implication of the hypothesis is true, but that is will not 100% guarantee to you that your hypothesis is true. For instance, the case in Semmelweis, he initially thought it was only from the dissection that the agent, this what he called faule tierische Stoffe, that means this kind of foul animal substances, was transmitted from the dead. But this is not true, because it was transmitted also from a cancer, cervix cancer. It was also transmitted from a knee, an infected knee. So, in fact, his initial hypothesis was wrong, but he could readjust afterwards his hypothesis and recorrect it. So, and in fact, what Semmelweis did is exactly what I explained to you before. Nomological network of cumulative evidence. This is exactly the example of a nomological network of cumulative evidence. So now in relation to causality, Semmelweis thought, and at that time, that in fact there was only a single causal agent that was even active, and it was transmitted from the dead. But then when he then saw that also these substances could be transmitted from other sources, the causality was a little bit broadened, because they did not yet have the idea that in fact it was one single agent. But of course, in Semmelweis' mind, it was probably, or he had already probably the idea of a single agent. And this, of course, has been the monocausality. At the end, from the multicausality, there's been a backshift to the monocausality, and which finally has been really ascertained by the discovery of the infectious agents and in the pathogen theory. So the causal relations now. The causal relations are in fact, first, he could purely do it by observation. For, let's say, I call this a priori, but it's maybe not the right expression, but it's by not doing any experiment, just by looking at data, at observational data. And the other, of course, is the interventionist approach. For instance, hand washing with a chlorinate solution, the exclusion of the ringing bell by the priest, or the validation, of course, through animal experiments. So Semmelweis' theory and medical practice was not accepted in his times, and he wrote a number of letters that he called often a brief, they were published, where really he went very harsh on, for instance, Dr. Spade and Hofrat Scanzoni, where he accused them that they were in fact doing things to kill, in fact, people, and because they do not listen to his theories, and they continue with their former theory to do things without taking into account that really the proof that in fact that childbed fever is caused by what Semmelweis described, so they didn't take into account. So he went really, really mad about it. And so he was a kind of Don Quixote figure fighting against windmills in his times. And he was isolated. He was isolated and opposed to the consensus, because the consensus was, in fact, that it was just atmospheric, cosmic, it's just like fatality, and so forth and so forth. Okay. And for instance, Ihre Lehre, Herr Hofrat, basiert auf die Leichen, die aus Unwissenheit ermordete Wöchnerinnen. So your teaching is based on the deaths that are resulting from your unwise doing, in fact. So it's I mean, in these letters, he went very, very, very aggressive, and he was very mad about that. And so he died really. People said it was a kind of beginning of psychosis, but it's not clear if that it was. It had a kind of burnout, and he died in a psychiatric institution. Probably he was beaten to death, but it's not yet clear how he died. So now the thing is that he was outside of the consensus. And just an example now from when you look on, when you do a media source research, there's been a person called Mike Caulfield who proposed the SIFT principle: stop, investigate the source, find better coverage, trace claims, quotes, media back to the original context. So that means that you have to be, in fact, to claim to have knowledge on the media, you have to be in the consensus. And so for instance, the sentence, his quick research showed a pattern, Mr. Kennedy. So this was one of the guys who did not follow the consensus in a specific claim. Mr. Kennedy claims were outside the consensus, a sign that they were motivated by something other than science. But this is not for science. You cannot, if you are outside of the consensus, you are not obligatory wrong what the Semmelweis case shows you. He was totally unorthodox. He was not in the frame of the present knowledge. But this, of course, what is for the internet is not for science. So never dismiss heterodox thinking, but be always careful about pathological science. Erwin Langmuir, he coined the term, the expression pathological science. And he did it by a talk in the colloquium at the Knoll's Research Laboratory in December 1953. This has been only transcribed here. And this was only by examples from physics, where he showed clearly that he identified a certain number of criteria where you can identify pathological science. For instance, where the maximum effect that is observed is produced by a causative agent of barely detectable intensity, and the magnitude of the effect is substantially independent of the intensity of the cause. or the effect is a magnitude that remains close to the limit of detectability, or many measurements are necessary because of the very low statistical significance of the results. And often the claims are of great accuracy, and fantastic theory often proposed contrary to experience are suggested. And criticism is met by ad hoc excuses, and the ratio of supporters to critics rises and falls gradually. So this is, he illustrated with a number of examples from physics, for instance, the N rays and so forth. So we have to be very careful also, because as Carl Sagan would say, for extraordinary claims, you need extraordinary data. And the data of Ignaz Semmelweis were at their times extraordinary. Case study 2, COVID-19.
Sorry to interrupt for a second. We're a little bit over time, and I want to leave some time for discussion. So I wonder if we could try to get through this in
7 or 8
I
will get to this. I will get, let's say, one minute or two, and it's fine.
Okay. Oh, certainly, yeah. I was thinking at least 5.
Yeah, okay. So I will do it just for, I mean, the case study COVID-19. Of course, we can talk about it in discussion. It was primary lung disease. Then it's a more systemic one. Then let's say the truth claims of in the mask has been changed gradually, and the truth claims of the origin of the virus also. So you have a number. You have also solidified truth in the COVID and truth fluctuations. So then there's the vaccination side effect. So there's vaccination-induced thrombotic thrombocytopenia, very rare when you compare to the general population. It's only with AstraZeneca, and it's due to anti-PF4 antibodies that have been generated. But it's clear that you have there are causality issues. That means the signal is pretty weak because there's high background sensitivity, but the time-dependent correlation, and also counterfactual evidence and a molecular explanation. So to finish for cancer, so there's a number of cancers, leukemias, invasive cancers, metastatic ones. And the important thing is that the tumor is evolving in a microenvironment where you have a lot of parts, you have blood vessels, you have matrix, inflammatory cells, immune cells, and so forth. And so I've written on this where we redefined the tumor environment, because it's not only a localized environment, but a more general environment where the whole organism is in fact involved. So you can read this paper afterwards. It's in Trends in Cancer. And you have intrinsic and extrinsic causes, and the causal, in fact, explanations will change during the progression of the tumor. Okay, so there are two theories, causal theories: the somatic mutation theory and the tissue organized field theory. So one is more the genetic one, the SMT, and the other one is the environment theory, is because the tissue environment should play a major role in this. So both theories are extreme, but the truth is in the middle ground. And of course, can ask what dominates the other, and we can discuss it later. Genotype dominates the phenotype, or the phenotype dominates the genotype. And this is, for instance, the hypothesis of Minabicel. So this is, I don't go onto this. We will stop here. I mean, you have a lot of causal explanation. You have two philosophies of cancer. You have deterministic, stochastic explanation. You have, for instance, causal intricacy and so forth. The causality is nonlinear. You have downward causation in cancer. And then, of course, you can compare infectious disease, which is, in terms of causality, very different to cancer, because cancer is You have causal pluralism, is multi-layered, less stable, not as specific. There's downward causation, not in infectious disease, is deterministic and stochastic, and is evolving during tumor progression. So it looks like more or less cancer like a cubic picture. So that's it. So just the concluding remarks. So there's the remark of Bertrand Russell on the top, but I just read the sentence of Toukaris and Sympopoulos. By denying truth and reality, science is reduced to a pointless, if entertaining game, a meaningless, if exacting exercise, and a destinationless, if enjoyable journey. Thank you very much. And this is for reading some of my articles and books, so you can consult. So thank you very much.
Thank you so much, Andreas, and apologies for rushing you a little bit at the end there. I wanted to make sure we had time for some questions, but a fantastic and really interesting talk, and extremely topical at the moment. I will remind the audience ways to ask a question. You can type something into the chat, which is the little quote button at the bottom. You can also, if you click the reactions button, you'll see a raise hand option. The reactions is one with the little smiley face and the plus. So if you raise your hand that way to ask a question, I will be able to see you. And otherwise I might not. I can see one question already from Robin. Is anyone else trying to ask a question and hasn't found the button? Just wave at me if that's the case. Looks like we have another question from Paul. So we'll go to Robin and then Paul. Robin, over to you. Remember to unmute.
Hi everybody. Andreas, that was fantastic. It was a wonderful description of scientific truth. Can you hear me? Yeah.
Yes, I can hear you very well.
Thank you. Yeah, I'm a little bit of a scientist myself, and funny enough, done a bit of work in circulation in bone, but that's another story. Okay, the question is about philosophy, really. Yeah. In scientific relativism, which you've described, I mean, we are very fortunate to be able to try and verify facts and create solidified truth, which you've beautifully explained. But even so, as you've also very well explained, it's incredibly difficult. Yeah. And there has to be a whole systems to do it. So my question is, do you think in philosophy, will we ever be able to get to the point in terms of social, political, and cultural relativism, perhaps using attitudes, semantics, value analysis? Will we ever get to that point in philosophy that we can try to achieve in scientific relativism in terms of developing systems to create a solidified truth in philosophy as opposed to science?
Yeah, I mean, there has been a tendency trying to do that. It was the Vienna Circle. I mean, the Vienna Circle with Schlick, Neurath, and Rudolf Carnap, Hans Hahn, and all this. They tried to do that, this kind of more scientific philosophy. Of course, it was mainly the philosophy oriented to language also. Yeah. But so I don't know. I mean, the problem is that I mean, in philosophy, so you may have often theories that are opposing, but they stand at the same time, so you cannot decide which one is the right one. So the problem is really there. It's the way you try to scientificize the philosophy. Of course, you have to be careful, because philosophy is not in that thing. Science is something that is above science and should be kind of explanatory scheme to explain some science. For instance, there's now the I mean, a whole field which is the philosophy of biology and the philosophy of cancer also. So there are philosophers, they're doing philosophy of cancer, of course. And this, to me, of course, when you go into these topics, they have to really to be articulated much more to scientific facts, you know. And if they are articulated more to scientific facts, then of course the value, the truth value of what they are implementing, what they are saying is higher, because it's more enshrined to scientific facts.
In philosophy, I mean, the only closest thing perhaps in science is psychometrics, in terms of attitude analysis and creating systems of attitudes related to, for example, skepticism or cynicism or nihilism. I'm just wondering if you had any thoughts that maybe in the future psychometrics might just begin to develop some form of solidified truth when it comes to philosophy. No, that was my only point. I'll say enough now. That's enough.
No, it's okay. It's well taken. Yeah. Okay.
Thank you.
We do have other questions. We've got, I think, Paul, you wanted to come in if you'd like to unmute yourself, and then Andrew.
I'm unmuted.
Paul, did you still have a question? Or
yeah, I can wait till after Andrew. I'm fine.
Oh, great. Let's go for Andrew next then.
I was wondering whether you ever refer to Karl Popper, because he had some interesting views on truth.
Yes, I mean, Karl Popper with the falsification, the criterion. Of course, it's. I mean, you can falsify. I mean, the major progress in science is through falsification, of course, and of course his ideas were more or less to, if you have an hypothesis that you cannot falsify, it's not a scientific hypothesis. Of course, it's implicit of what I'm saying. And when you look on the Hempel, what Karl Hempel said in his book, it's into this direction. You know, it's applying also the falsification. So you can easily, if you can falsify a theory, a biological theory, then if you can falsify a hypothesis in the biological theory, then you can easily reject it. But when you have only the verification, so when you verify it only, then of course it's not sure that your hypothesis is correct. Of course, the falsification is always stronger than the verification.
But the falsification merely limits the value of the hypothesis.
Yeah, it limits the value of the hypothesis, but if the chances of falsification of your hypothesis is high, then your hypothesis is strong, according to Popper in theory.
Yeah,
of course. So that's, I mean, it's a little bit implicit, but of course it's not. Of course, you have also to. It's often a combination between falsification and verification, because when you run an experiment, then you verify it, and you have all the controls that you have put really also to falsify it to some extent, you know. So it's in fact in both directions.
Thank you, Andrew. Let's go to Paul, and then we have a couple in the chat, which I will read out. So Paul, if you can keep your question fairly brief, we'll go on to those others as well. Paul, you're back on mute. There you go.
Right. Hello. I'd like to thank you for the talk, and also I'd like to thank. I'm talking to a fellow John McLaughlin fan, so that is always good in my view. And somebody who owns an Al Di Meola black guitar.
I'm a John McLaughlin fan, so I have a lot of guitars. I have 25. You know.
Right. So instead of us talking about John McLaughlin and Billy Cobham, we'd better have a conversation.
Yeah.
David Hume once said that there is no species of reasoning more common and more useful or more necessary to human life than that which is derived from the testimony of men and the reports of eyewitnesses and spectators. Now, I just wondered, with what you said towards the latter part of your discussion, how we can actually get around this, because sometimes we think in terms of, Joshua Green described it as having an automatic focus on beliefs, and that sometimes it's like an automatic camera, and that sometimes we need to take the automatic focus and the camera off, and we need to delve more into the theory itself and understand more about it. Now, initially, when you do this would be very difficult to explain to somebody. So how would you get around that, explaining a very difficult theory, and persuade somebody to suspend the judgment initially before you could progress within it?
So if I understand you well, it's I mean, when you have a belief, you mean you have a belief system, then you suspend your belief, and then you and then you try to re-examine the facts like they are. I mean, there's an example, for instance, what William Harvey did. So William Harvey, when he discovered the circulatory system, you know, the idea was they had all the theory and the writings of the times from Galen and all this, because and all the physicians, they were explaining that just by illustrating and commenting some of the writings of Galen and so forth, and Harvey suspended entirely this. He cut it off. He said, I don't want to listen to these former theories. I suspend them totally. I just do and see for myself. And the suspension is in fact done at the moment where you go to when you tackle an empirical point of view. So the empirical point of view may suspend some prior belief that you have and may question it. And I think William Harvey is a very good example of that, because he did it. He did it from the ground. He just said, I have my reason, I have my eyes and my thinking and my brain, and I will examine the facts, and we'll do tests and hypothesis testing. So that's and he suspended the entire belief that existed in his times.
Mm.
So,
thank you, Paul and Andreas. So a couple from the chat. We've got a question from Ian wondering if consensus is the difference between science and philosophy, or at least an indicator of when we're doing science. There is some consensus, and when we're doing philosophy, there is none. And then we have a question from Colin Aldridge, aka Dad. Is truth a relevant criterion for science at all? Or is science just a best explanation of what is the case? So there's no idea that it's probably true, but it's useful in practice, a sort of pragmatist view, I suppose.
yeah,
So
I think
why
so.
why does science have to be true rather than just useful at the moment?
Okay, so for the consensus, you know, so the consensus, of course, you have in science, you have a consensus that is emerging at a specific times, of course. So for instance, the consensus that you have, for instance, DNA, and DNA codes for proteins and for RNA and so forth. And this has been a general consensus. But the consensus can be broken because in some instances, I mean, the theory was DNA goes to RNA and then protein, just one line, okay? But you have feedback now. That means that what, in fact, how a team has found you can retro-transcribe RNA that can be, in fact, reconverted into DNA. Okay, so in fact, and this has caused a lot of stirs in his time, and he was outcasted. He was outside of the consensus because he said, I have the enzyme, identify the enzyme that can do that in the cell. And in each talk where he went, he was laughed on. But at the end, he was right, and he got the Nobel Prize. Okay, so there is this kind of group thinking in science too. It's pretty heavy, yeah. So the group thinking. So in philosophy now, so the group thinking. I mean, I don't know. I'm not. I mean, as much as a philosopher as a scientist, so I can. I mean, it's hard to comment. But you have a lot of schools in philosophy, independent ones, and they are, in fact, they exist. So they fight against each other from time to time, but they do not, let's say, exterminate each other. So maybe this is the answer, that you have, in fact, more stable consensus in science in some aspect, and not in philosophy. But
can I just add to my question?
Yes, please.
I just got a feeling that science is gradually crowding out philosophy, and it's coming more and more into what used to be philosophy has now become science.
Yeah, has
become, the atomic theory, I can't remember, was it Thales? I can't remember who came up with the atomic theory first, but he was a philosopher, and there wasn't any consensus. But now it's science, and there is. And it's happening in neuroscience, and it's happening with evolution, and science is taking over big areas of philosophy. Because in philosophy, there used to be no consensus about it, lots of arguments. And now science is just, there is a consensus. Yes. So I just think that philosophy is being diminished all the time by science.
Yeah, that's right, because the philosophy is more speculative, and the science, they're doing experiments. Of course, they can take on some of the philosophy, and it has been done, some of the philosophical theories, and they do experiments, and they solidify, in fact, some of the theories. So science is in fact a solidified philosophy. To some extent.
Yeah.
Thank you, Ian and Andreas. We're coming to the end. Did you want to say anything about pragmatism? Why science needs to be true rather than just useful? Is there a difference?
I mean, truth. I mean, you have. If you say only useful, that means it's useful in a certain context, certain circumstances, but in another context, and if the circumstances changes, it could no more be useful. So that means there is no stability when you talk about use. There's no stability. And when you talk about truth, there's stability. That means that you have, for instance, when you look at the cell theory and all this, I mean, these are very stable theories. And so you can even look at the objects. You can measure them. So you have a lot of data that in fact will show you that these are really solidified concepts and entities, and not just useful for a time being, or for a society, or for a cultural context. Because when you talk about use, that maybe, I mean, look, in the ancient, the theory of the theory of the humors, so you had the theory of the humors, that in fact in the Middle Ages and before the scientific revolution, you had to equilibrate the humors to get healthy. Okay, and this is a totally wrong theory. This is wrong. Even at that time, you could say, okay, their epistemic environment was like this, so they explained nature in this way or in this way. But it's in fact, when you look at the facts, it's wrong. It was not a scientific theory. It was an analogic theory to forces that have been outside water, the earth and the sun and so forth. It was not enshrined in a scientific reasoning. And of course, it's what we have now is truth in comparison to what was before. That's why I say it's not, I mean, the pragmatic point of view is, I mean, for me, it's not really, it's not really holding the ground. No.
Thank you, Dad and Andreas. I think we'll wrap up in a second. I just wanted to give you the chance to speak for a minute or two, Andreas, on your final slide. You seem to be suggesting there that there was or there is a trend towards irrationalism, a dangerous trend. Do you see science as particularly under threat at the moment? And if so, what do you think that threat is?
No, I mean, there is so there are some movements in society, some social movements that are in fact quite irrational, and these movements come from the right and from the left. Okay, so they come in fact from both sides, and they attack in fact the values that came out of the Enlightenment. Okay, and this is the big problem, because the rationalists, the liberals, the classical liberals, they stay a little bit in the middle. I mean, even the classical lefties, you know, who believe in universal values, in reason, science, Enlightenment values, this is very heavily attacked. And for instance, all this movement about post-truth, you know, all this stuff of Trump and what you see from the Trumpian side was coming. I mean, this was pretty obnoxious, where they bluntly, in fact, questions, in fact, basic scientific principles on COVID, you know, with the transmission. But also it can come from the left. So you have it also from the left, that things are becoming quite, let's say, quite irrational. And the problem is, for reasonable people, we have to stand our ground, you know, to defend, in fact, the Enlightenment values and what made, in fact, the West, in fact, great. Let's say the good things of the West, not the bad. So we had the concentration camps also here, and we had also the Gulag and all this, but we had also Einstein, we had John Stuart Mill, we had all this kind of absolutely incredible people, composers, musicians, scientists, intellectuals, and this we have really to cherish and to protect, you know.
Thank you so much, Andreas. A great thought to close on. Would like to say thank you to you on behalf of everyone for joining us and for an excellent talk and for answering our questions so thoughtfully. And thank you to everyone for attending. I'll just remind you that we have another talk in 4 weeks' time. We'll have second Tuesday in May as usual, and that is going to be the 11th of May. So that will be on the website, and you can register there if you like. It will be Andrew Ward talking about determinism and moral responsibility. So if events are determined, you know, fully fully determined by prior causes and could not have been otherwise, what sense can we make of moral responsibility in that context? Or more specifically, what sense did Kant make of it in that context? So it should be a really interesting talk.
Yeah.
We are also tentatively moving towards an in-person event in July. Remember those, which we hope will be at the OSO in Barnes. So we'll circulate more details as those become confirmed, but we're looking at July the 13th. So let's pencil that in. Huge thank you again to Barbara for the introduction to Andreas. We really appreciated that. And I would like to just close by thanking everyone for attending. I hope you enjoyed it.
Yeah, thank you.
Thank you.